Hi everyone. So today we are going to learn the basics of vector addition and vector subtraction. For that, we need to understand few basic concepts and few misconceptions that always occur. Okay? To have a greater understanding of two-dimensional motion, we need to understand how the vector is working. First of all, we need to know what a vector is. Hope in the previous classes you might have heard a vector is something that has a magnitude and a direction. Okay, for example, a force. If we apply a force in this direction, it has a force of few newtons, maybe we can call it as 5 newton, and it is acting in this direction. So something which has a magnitude and direction is called a vector. So now we are going to know how two vectors are getting added. Okay, let's see. This is a vector A and this is another vector B. Okay, so vector A and vector B, these vectors we need to add. So what is A plus B? In the words of physics, we'll say that what is the resultant of vector A and B. Okay, in the words of physics, we'll say the resultant. We'll not say A plus B. The resultant means the addition. Okay, so we need to add the vectors A and B. How can we add? For that, we need to understand from the reality of life. Okay, there are few calculations that can be done using the mathematical operations, but I really want to understand the concept of it. Okay, for that I want you to imagine two vectors as a force that is exerted on me. Okay, just I want you to imagine these are the two forces that is getting exerted on me. Okay, now we will get the first vector A. So this vector is a force that is pushed on me in this direction. You're getting right? So somebody is pushing me in this direction. Okay, and B is another vector. So some other person is pushing me in this direction. Some guy is pushing me in this direction and some other person is pushing me in this direction. Okay, so we have compared these two vectors in such a way that two person is pushing me in these directions. So now you will get an idea. If a person who has pushing me in this direction with this much of force and another person is pushing me in this much of force. Okay, let it be of around 10 Newton and let it be 7 Newton. Okay, so now you have to tell me if a guy is pushing me this way and another person is pushing me this way. So what will be the motion of me? So you can have a guess like it might be in this direction. It might be in this direction. Not exactly as the direction as the first person is pushing me. So it will be in this direction. So that you can get it from just your logical understanding. Okay. So from this logical understanding, we have got that the result is like, result might be this kind of in this direction. The A plus B must be in this direction. So this is what logics teaches us. Okay, now we need to understand from a mathematical perspective how these two vectors are getting added. Okay, let's see what are the possibilities and what are the chances of getting this as a resultant. Okay, to add two vectors mathematically we have two rules. Okay, both will get same answer, but there are two rules. One is triangular law of vector addition and parallel law of vector addition. Okay, for the triangular law of vector addition, for that, see, we have taken the vector A here 10 Newton vector and the B here 7 Newton vector. Okay, to do the triangular law of vector addition, we need to either keep the top of a vector to a tail of another vector. you can do vice versa. Okay, either you can get the top of the vector to the tail of another vector, or top of the first vector into the tail of another vector. Okay, see, if I am taking this vector and the top to the tail here, so if I make it here A, so the resultant should be like this. See, it is somewhat similar to the direction that we have found while we are calculating logically. Okay, this is triangular law. Either we have to keep the top of first vector in the tail of another vector, or you can put the tail of this vector in the top of this vector. Now also we will get the same. Now we are moving to parallelogram of law of vector addition. Parallelogram law of vector addition. In this is somewhat similar to triangular law. Okay, see, we have vector A here, we have vector B here. We have to keep the tail of first vector to the tail of another vector. Please don't get confused. For the triangular law, what we have done is that the top on tail, any of the vectors, top on tail or tail on top. For the parallelogram law of vector addition, we have to keep the tails together. For the keeping tails together, I am taking B here and keeping it here, B. And I have to draw lines parallel to both the vectors. Parallel to A, if I draw a line here, it will be like this. Okay? And parallel to B, if I draw a line here, it will be like this. So now we have to join this one. This will be the resultant. A plus B. It is again similar to what we have told, what we have found logically. Okay. So now we have found the resultant of two vectors using two law, parallelogram law of vector addition and triangular law of vector addition. And for you not to get confused, what I have found is a very easy method to know the direction of the resultant of the two vectors. Okay. Now we are moving to finding the vector components of any of the vectors. Vector components of any of the vectors. I'll explain what a vector component is. Okay. See, I'll take the example what I have mentioned earlier. A person is pushing me in this direction. Okay. This one. A. A person is pushing me in this direction. So I'm about to fly in this direction. Okay. So while considering my motion in this direction, I have a horizontal movement and a vertical movement. Am I right? If I'm moving in this direction, I am moving leftwards and I am moving upwards. Am I correct? That is the motion, right? So how long or how far I am moving in horizontal direction means its horizontal component. Okay? And similarly, how far I move in vertical direction is called the vertical component of the vector. It is as simple as that. Okay? So consider these two, or you don't have to consider these two, just consider this one. See, if we consider vector A, so it is having a horizontal movement of this much and it is having a vertical movement of this much. Am I correct? So if we put this vector in a two-dimensional space, let it be a xy axis, if this is vector A, and if it is corresponding to 1 in x-axis, and if it is corresponding to 5 in x-axis, and similarly here 1, and similarly here 6, means it is having 5 units in y direction, it is having 4 units in x direction. So vector A is having the vector components 4 in x-axis, 5 in y-axis. So these are the vector components. You got me? So in this class we have learned two things. One is the resultant of two vectors, which is the addition of two vectors, that we have found the direction very logically using two people pushing. Okay, and we have found the mathematical way of solving the resultant of two vectors using triangular and parallelogram law of vector addition. And now we have understood what exactly are the vector components of a vector. Okay, the horizontal movement, the horizontal component, as well as the vertical component. Now you understood that. Okay, thank you so much.